Good morning. Our topic for today is navigation with ECDIS. To perform bridge operating procedures, the navigators must understand the main safety setting for the shallow contour, safety depth, safety contours, and deep water. In order to set them properly, in order to firstly avoid unwanted incidents and then to achieve a sensible implications, shallow contour value is used to tell ECDIS that the value of shallow water for our draft. This is the value of depth below which it is definite for the vessel to get aground. The shallow contour value need to be equal to or more than the draft of the vessel. Safety contour is the contour line above which we can navigate without any water depth concern. Safety depth is the only depth setting on ECDIS. It is the depth of the water we can safely navigate upon. Deep water contour is a relative term and user is free to set as per what he believes could be deep water for him. Entering the safety setting will warn us with an alarm when vessel enters in shallow waters. Danger detection setting can help in giving pre-warning of the dangers ahead. We only need to define the area in which we need the ECDIS to warn. To activate bridge functions, setup and use of ECDIS alarms. Alarms are another issue on ECDIS. Due to many alarm indicators and warnings, most OOWs due to alarm fatigue prefer to turn the alarms in silent mode. Deck officers who are unfamiliar with the setup and use of ECDIS alarms have been involved in groundings in shallow waters incidents and other unfavorable situations. A clear policy regarding ECDIS alarms handling will guide the OOWs to the appropriate awareness level during their watch. SQE Marine has prepared a checklist aiming to provide the necessary steps required to ensure vessels' proper ECDIS setup. To navigate with ECDIS effectively, the implementation and use on board of ECDIS has reduced navigation risk. Ship groundings and collisions can be avoided if ECDIS is used correctly. With all alarms set properly, safety is also improved if navigators refer regularly to other navigation aids, such as radar, and maintain situational awareness by looking out of the bridge window. Extensive training of bridge teams in the use of ECDIS and other systems is also an important element of safe navigation. The use of ECDIS and electronic navigational charts on ships has reduced the number of casualties. Said ship insurer UK and PNI Club's loss prevention director Stuart Edmonston, ECDIS can improve the safety of navigation. For example, it has significantly improved the accuracy and reliability of navigation charts. He explained corrections and updates such as wreck and cable positions used to be added manually on paper charts, but with ENCs, the corrections are added automatically by way of CD or downloaded through the ship's satellite communication. Overlays are also possible with data from the Automatic Radar Plotting Aid or ARPA and Automatic Identification System or AIS superimposed over ENCs. ECDIS, which is now a mandatory shipborne navigation equipment for voyage planning and execution, can operate a variety of charts. The official charts are known as Electronic Navigation Charts or ENCs and Admiralty Raster Chart Service ARCS. The charts are made and distributed by hydrographic officers through a distribution network, and the vessel has to subscribe to a service provider. ECDIS uses digital charts vectorized and raster charts for navigational duties usually carried out with paper charts. The equipment must be type approved and uses up-to-date official charts as long as the area covered by vector charts is small. The ECDIS should be able to cover both vector and raster charts. When operating in raster mode, an ECDIS must be used together with an appropriate folio of up-to-date paper charts.